Okay, this is going to be a video on the proof of the product rule. In a previous video I showed that the definition, or I showed some intuition behind the definition of the derivative, and the derivative is defined as f prime of x, or dy by dx, is equal to the limit as delta x approaches 0 of f of x plus delta x minus f of x all over delta x. This is essentially just the grading, but you can watch that in my other video. The product rule is for two functions multiplied together. So if you have u as a function of x and v as a function of x, and you want to find the derivative of u times v, then use the product rule as the product, because the functions are being multiplied, is equal to u times the derivative of v plus v times the derivative of u, and we are about to show that. So, if we have two functions f of x and g of x, then the derivative of them, I just write d by dx of f of x times g of x, that's going to be equal to the limit as delta x approaches 0 of the function plus delta x, so it's going to be f of x plus delta x, g of x plus delta x, minus f of x, g of x, all divided by delta x. With that, you can't do much. It doesn't seem. But what we do is we essentially add 0 onto the numerator, so it doesn't change. Just a trick of mathematics is similar to multiplying something by 1 in a particular way. It is the same thing, and you can manipulate it. So what we're going to add and subtract is f of x and multiplied by g of x plus delta x. So if we have the limit as delta x approaches 0, this is going to be a long numerator. I might just actually get rid of that so that I have a bit of room. No, I won't. I'll just draw a line underneath that. So we've got f of x plus delta x, g of x plus delta x, minus f of x, g of x. Now plus f of x, g of x plus delta x, minus f of x. Can you still see this? G of x plus delta x. That's a long numerator. But luckily we can do some factorizing, because this is the limit as delta x approaches 0 of, you've got an f of x plus delta x here, and a g of x plus delta x here, and we've got a g of x plus delta x here. So we're factoring out these from each other. We're factoring out the g of x plus delta x. So this is going to be g of x plus delta x multiplied by f of x plus delta x minus f of x, and then these two things will cancel, or will go away from the expression. So f of x plus delta x minus f of x, and all of that is over delta x. Then we add, we've got an f of x here and an f of x here, and this is being subtracted, so we've got f of x times g of x plus delta x minus g of x, because this is a minus here, so g of x plus delta x minus g of x and then similarly that's divided by delta x, but we can just say that this is multiplied by this over delta x, it's the same thing. And now we observe that f of x plus delta x minus f of x over delta x is as delta x goes to 0 is the definition of derivative. Similarly with g of x plus delta x minus g of x over delta x is also the definition of the g prime. So we can rewrite this as g of x plus delta x coming from here is the limit as delta x approaches 0. G of x plus delta x times f of x plus delta x minus f of x over delta x is f prime of x. And we're adding f of x times, same thing here, g prime of x. And essentially we're in the home stretch. This is more or less it. So in general, we've got that if we have u and v as functions of x, as I think is written in most textbooks, f d by dx, so just a derivative function of u times v, operator rather, I said function, I meant operator, is equal to u v prime plus u prime v, where f of x is v, so then that's going to be v prime, and g of x is u, and so you could rewrite that as v